All right, let's jump right into this explainer. Look, we've all seen the viral clips, right? The robots doing backflips, perfectly folding a t-shirt, or calmly handing someone an apple. It's incredibly cool, but honestly, it's also a lot of noise. So today, we're going to look completely past that shiny sci-fi exterior. We are going to tear down the actual engineering, pinpoint the real physical choke points in the supply chain, and figure out which companies are genuinely making money in this space right now.
To understand the scale of the hype, just look at Morgan Stanley. They recently put out this staggering projection, predicting that humanoid robots could be a 5 trillion, yes, trillion with a T, global market by 2050, with over 1 billion of these things walking around. I mean, that is a massive number, which naturally begs the question, how much of this is real today and how much is just aspirational?
Because right now, it is literally a tale of two realities. On one side, you've got the boardroom hype, like Elon Musk projecting that Tesla's Optimus alone could bring in 30 trillion in annual revenue. But then, you look at the actual boots-on-the-ground warehouse pilot programs. Take logistics company GXO, for example. In their tests, humanoids are still really struggling with basic dexterity. They move kind of slowly, they occasionally drop boxes, and they absolutely still need a human teammate right there to supervise and fix their mistakes.
So here is how we're going to break this down today. 1. Beyond the humanoid hype. 2. Anatomy of a humanoid. 3. Identifying the supply chain moat. 4. Public companies cashing in. And finally, 5. Evidence of real deals.
Okay, Section 1. Beyond the humanoid hype. Sizing up the true state of the market.
So what is the actual timeline here? Well, while the long-term projections are astronomical, the near-term reality demands some very specific milestones. Goldman Sachs is projecting a $38 billion market by 2035. But for that to happen, build costs have to plummet. We're talking a 40% drop just to get into that $30,000 to $150,000 sweet spot. And a huge catalyst for the whole industry is Tesla's Optimus, which is targeting the start of production for the summer of 2026. Actually, keep in mind, that's just the start of production. True high-volume scaling, that's more likely a 2027 story.
Moving on to Section 2, Anatomy of a Humanoid, a physical teardown of the machine. Let's actually look under the hood. If you break down a humanoid, it's essentially a highly precise stack of 4 main things. You've got the AI compute brain, think NVIDIA's Jetson Thor or Tesla's custom FSD chips, processing the world through cameras. Then you have the sensors, keeping the whole thing balanced. You've got a 2 kilowatt-hour lithium-ion battery pack sitting right there in the torso. And finally, you have between 28 and 58 electric actuators. All of this works together in a continuous, incredibly fast sense-plan-act loop.
Now this right here, this is the most crucial part of this entire explainer, the actuator. It is literally the muscle of the robot. And what you really need to grasp is that a single rotary actuator is essentially an expensive sandwich made up of a frameless electric motor, a precision reducer gear, and torque sensors. Just those 3 pieces make up about 80% of the cost of every single joint. Bottom line, if humanoids are ever going to scale, this exact component has to get way, way cheaper.
And it's amazing how engineers are just directly copying human biology to solve these physical problems. You basically have 2 main types of actuators. Rotary actuators handle smooth, circular movements, perfect for shoulders and hips. But for the knees and ankles, engineers use linear actuators with planetary roller screws. These act exactly like your quadriceps tendon. Think about the shock of taking a step. These actuators allow the robot to absorb a massive 2 to 3 times its own body weight every single time its foot hits the floor.
And how you arrange these muscles completely changes the game. If we look at deep dives into leg designs, there are 2 totally distinct philosophies right now. On the left, robots like the Unitree G1 use a pitch-roll-yaw sequence. Because the pitch actuators are side by side, they can be sandwiched together for really tight, efficient packaging. But on the right, Tesla's Optimus uses a roll-yaw-pitch design. Putting that roll actuator first means the leg generally needs more physical space to clear itself when pivoting outward. So the sequence of these joints is like a giant puzzle. It dictates the physical space needed and even the torque you need from the base motors.
All right, Section 3, Identifying the Supply Chain Moat, where the real competitive advantages lie.
When we zoom out and map this all out, a massive geographical divide emerges. The US is absolutely dominating the brain of the robot, with companies like NVIDIA and Tesla. But the physical body? Totally different story. The precision reducers that act as the robot's joints and the high-powered magnets required for its motors are heavily bottlenecked in Asian supply chains, specifically in Japan and China.
Which brings us to the massive elephant in the room, the rare earth magnet bottleneck. Just to put this in perspective,
Every single Tesla Optimus needs roughly 2 to 3.5 kilograms of highly specialized neodymium magnets. China dominates the supply right now, and past export controls have literally disrupted production before. This dependency is probably the single biggest structural risk and moat in the entire hardware space. It makes companies that can secure the supply, like MP Materials trying to build a domestic U.S. pipeline, incredibly strategic players.
Which leads us perfectly into Section 4, Public Companies Cashing In. The picks and shovels investment narrative.
So, rather than guessing which robot brand is going to win the race, let's look at the picks and shovels companies, the ones supplying the parts everybody needs. You've got NVIDIA trying to standardize the AI brain. You have MP Materials attacking that magnet bottleneck. And then you have the unsung heroes, the motion control and sensor suppliers, like Regal Rexnord, Novanta, and Vishay Precision Group. Tracking these companies is how we follow the actual financial flow of the industry, instead of just getting swept up in Twitter hype.
Finally, Section 5, Evidence of Real Deals, separating the aspirational from the actual. $200 million. That is the opportunity funnel that Regal Rexnord CEO just recently confirmed they are actively working on across robotic and humanoid actuation. That is not small change. That shows massive, legitimate enterprise interest.
But let's bring it back down to earth for a second. Out of that massive $200 million funnel, Regal Rexnord only saw about $1 million in actual booked orders in their last reported quarter. So yes, the interest is huge. But this absolutely proves we are still firmly in the prototype and sampling phase, not the mass manufacturing phase.
Now, if you want cold, hard proof of repeat buying, check out Vishay Precision Group's annual report. They make force and strain gauge sensors, and they officially noted orders from 3 different humanoid developers, plus a follow-on order. This is exactly what you want to see. Clean, undeniable evidence that serious repeat purchasing is happening right now down in the supply chain. On the flip side, we have to stay objective here and acknowledge the reality checks. Take this super honest admission from the CEO of RBC Bearings, a major parts supplier. He straight up said they don't see high volumes from anybody yet. Everyone is still just making samples. It's a sobering reminder that, despite the viral videos, true high-volume humanoid manufacturing just isn't here yet.
So, as we wrap up this explainer, I'll leave you with this. The humanoid robot revolution is definitely real, and physical AI is helping engineers clear hurdles faster than we've ever seen. But the actual timeline to true commercial scaling, that totally depends on unblocking these supply chains and crushing the cost of components like those actuators. So, the next time you see a robot doing a backflip on your feed, are you going to be distracted by the shiny metal? Or are you going to be thinking about the precision actuators, the sensors, and the chips that are actually making it all happen?